Hello, everyone. In this video, we will answer an exam about continuity. Part 1. Determine the continuity of the algebraic function. Number 1. f of x equals x cubed plus 5x squared minus 24x.
Solution. F is a polynomial function. Therefore, it is continuous on its domain, the real line. In other words, it is continuous everywhere.
Number 2. r of x equals 1 over quantity x cubed plus 5x squared minus 24x.
Solution. R is a rational function. It can be written as f of x equals 1 over the product of x and quantities x plus 8 and x minus 3. It is discontinuous when the denominator is 0. Therefore, R has infinite discontinuities at these numbers. R is continuous on its domain D.
Number 3. f of x equals 1 over quantity x squared minus 5.
Solution. F is a rational function. It is discontinuous when the denominator is 0. Thus, f has infinite discontinuities at x equals negative square root of 5 and x equals square root of 5. Moreover, f is continuous on its domain D.
Number 4. r of x equals x cubes plus x squared minus 9x minus 9.
Solution. R is a rational function. It is discontinuous when the denominator is 0. Hence, R has a discontinuity at x equals negative 1. However, it is not an infinite discontinuity because the numerator is also 0 at x equals negative 1. Rewrite and simplify R. Thus, the graph of R is a parabola. The figure on the right shows the graph of f. However, because R is discontinuous at x equals negative 1, it is undefined or has a hole at x equals negative 1. In summary, R is continuous on its domain D.
Number 5. f of x equals x plus 1 all over quantity x cubed plus x squared minus 9x minus 9.
Solution. F is a rational function. It is discontinuous when the denominator is 0. Rewrite f as f of x equals x plus 1 all over the product of quantities x squared minus 9 and x plus 1. or 1 over quantity x squared minus 9. F has a whole discontinuity at x equals -1. Meanwhile, F has infinite discontinuities at x equals positive and -3. In conclusion, F is continuous its domain D. The figure on the right confirms the conclusion that F is discontinuous at x equals -3, -1, and 3.
Number 6. F of x equals the square root of x, if x is greater than or equal to 1, and 1 minus x, if x is less than 1.
Solution. For a piecewise function over the real line, -infinity, positive infinity, check the continuity on subintervals -infinity, 1, and 1, positive infinity. The continuity at the transition point x equals 1. First, continuity on the subintervals. f1 of x equals square root of x is defined and continuous when x is greater than or equal to 0. Hence, f is also continuous for all x greater than equal to 1 or on the interval 1, positive infinity. f2 of x equals 1 minus x is a polynomial, which is defined and continuous for on the real line. Hence, f is also continuous for all x less than 1 or on the interval -infinity, 1. Second, continuity at the transition point. At the transition point x equals 1, the equation for continuity at a point must be satisfied. The limit of f of x, as x approaches 1, equals f of 1, which entails the following conditions. A. Is f of 1 defined? Because x equals 1 is at the domain x greater than or equal to 1 of f1. f of 1 equals 1. Hence, f of 1 is defined. B. Does the limit of f of x, as x approaches 1, exist? The limit exists if the one-sided limits are equal. Because the one-sided limits are not equal, the limit of f of x, as x approaches 1, does not exist. C. Is the limit of f of x, x approaches 1, equal to f of 1? The limit of f of x, as x approaches 1, does not exist, even if f of 1 is defined. In conclusion, f is continuous on both subintervals, -infinity, 1, and 1, positive infinity. but it is not continuous at x equals 1. In other words, f is not continuous on its domain, the real line.
Part 2. Determine the continuity of the following functions. Number 1. F of x equals the tangent of pi x.
Solution. The trigonometric function. The tangent of a variable, say w, where w is a dummy or a temporary variable, has infinite discontinuities at w equals n pi over 2, for n equals positive or negative 1, positive or negative 3, and so on. The figure on the right illustrates the graph of f in terms of a temporary variable w. F of w equals the tangent of w has infinite discontinuities at w equals positive or negative pi over 2, positive or negative 3 pi over 2, and so on. Let w equals pi x. The given function f of x equals tangent of pi x has infinite discontinuities at x equals n over 2. For n equals positive or negative 1, positive or negative 3, and so on. Thus, f is continuous for all x except at x equals positive or negative 0.5, positive or negative 1.5, and so on. The figure on the right illustrates the graph of f in terms of the given variable x. F of x equals the tangent of pi x has infinite discontinuities at x equals positive or negative 1 over 2, positive or negative 3 over 2, and so on.
Number 2. F of x equals the inverse sine of x over 4.
Solution. The inverse trigonometric function, the inverse sine of a temporary variable, say w, is defined and continuous at all w in the interval -1, 1. The figure on the right illustrates the graph of f in terms of a temporary variable w. F of w equals the inverse sine of w is defined and continuous on the closed interval -1, 1. Let w equals x over 4. The domain D of the given function f of x equals the inverse sine of x over 4 has endpoints at x1 equals -4, x2 equals 4. Thus, f is continuous at all x in the domain -4, 4. The figure on the right illustrates the graph of f in terms of the given variable x. F of x equals the inverse sine of x over 4 is defined and continuous on the closed interval -4, 4.
Number 3. F of x equals the secant of 3x.
Solution. The trigonometric function, the secant of a dummy variable, say w, has infinite discontinuities at W equals n pi over 2 for n equals positive or negative 1, positive or negative 3, and so on. The figure on the right illustrates the graph of f in terms of a temporary variable w. F of w equals the secant of w has infinite discontinuities at w equals positive or negative pi over 2, positive or negative 3 pi over 2, and so on. Let w equals 3x. The given function f of x equals secant of 3x has infinite discontinuities at x equals n pi over 6 for n equals positive or negative 1, positive or negative 3, and so on. Thus, f is continuous for all x except at x equals positive or negative pi over 6, positive or negative pi over 2, and so on. The figure on the right illustrates the graph of f in terms of the given variable x. F of x equals the secant of 3x has infinite discontinuities at x equals positive or negative pi over 6, positive or negative pi over 2, and so on.
Number 4. F of x equals 7 times the cosecant of x.
Solution. The trigonometric function, the cosecant of w, where w is a temporary variable, has infinite discontinuities at w equals n pi, for n equals 0, positive or negative 1, positive or negative 2, and so on. The figure on the right illustrates the graph of f in terms of a temporary variable w. F of w equals the cosecant of w has infinite discontinuities at w equals 0, positive or negative pi, positive or negative 2 pi, and so on. With w equals x, it is straightforward that the given function f of x equals 7 cosecant of x also has infinite discontinuities at x equals 0, positive or negative pi, positive or negative 2 pi, and so on. The figure on the right illustrates the graph of f in terms of the given variable x. F of x equals 7 times the cosecant of x has infinite discontinuities at x equals 0, positive or negative pi, positive or negative 2 pi, and so on. Meanwhile, the scalar factor 7 does not affect the locations of the infinite discontinuities in this case. But it does affect the range, as shown in the figure.
Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.